In this second class of Chapter 7 of the course of Basic Geometry, the following topics are presented: definitions about the hyperbola curve, eccentricity of the hyperbola. In this first slide of this second class of Chapter 7 of this course of Basic Geometry is present the curve of the hyperbola. The hyperbola curve is a curve of the group of conic curves, since it is originated from a section of a cone truncated by a plane. In the case of hyperbola, the angle of the plane with respect to the base of the cone is greater than the angle that the generatrix of the cone has with the base of the cone. Figure 7.7 presents the main elements of the hyperbola. In this second slide of this second class of Chapter 7, the characteristics of the hyperbolic curves are present. The curve called the hyperbola is defined as the locus of points in a plane, in which the difference of the distance of points of the curve from two fixed points has a constant dimension value. These two fixed points of the plane are called the foci of hyperbola, and they are called the f1 and f2. The distance between the two fixed points is called the focal distance, and is known as f. The central point between the two foci of the hyperbola is called the center of the hyperbola, and is called by the letter capital O. In this third slide of this second class of Chapter 7, it's continuing the presentation of the characteristics of the hyperbolic curves. Are called the radial vectors of the hyperbola the line segments that connect any of the curve's points to each of the focal points. The difference in the dimension of the radial vectors from a point of the curve to each of the foci of the hyperbola is constant, called the constant of the definition of the hyperbola, and is called using this lowercase letter c. In this fourth slide of this second class of Chapter 7, it presents the continuation of the presentation of the characteristics of the hyperbola. Let be two points of the hyperbolic curve, M1 and M2. By definition of the hyperbola curve, the dimension of the line segment M2F1 minus the dimension of the line segment M2F2 has the value of the constant of the definition of the hyperbola, represented by the lowercase letter c. The same is also true for point M1, where the value of the dimension of the line segment M1F2 minus the value of the dimension of the line segment M1F1 has the same value of the constant of the definition of the hyperbola. These 2 points belong to two different branches of the hyperbola. These two branches of the hyperbola do not have common points. For these relations presented to be true, it is necessary that the constant of the definition of the hyperbola has a value less than the focal distance f. That is, c must be less than f. In this fifth slide of the second class of Chapter 7, it's presented the continuation of the characteristics of the hyperbola. It is drawn a line segment connecting the two focal points, f1 and f2. This straight line segment is called the transverse axis of the hyperbola. If it is marked on the transverse axis 2 points, a1 and a2, belong to the hyperbola curve, the following is true. The dimension of the segment of the line A1F2 minus the dimension of the line segment A1F1 is equal to the constant of the definition of the hyperbola, and the same is true for the segment lines A2F1 and A2F2 line segments. The points A1 and A2 are called the vertices of the hyperbola. In this sixth slide of this second class of Chapter 7, it's presented the continuation of the characteristic of the hyperbola. All the points of the two branches of the parabola are symmetrical with respect to the transverse axis. Points A1 and A2 are called the vertices of the parabola. If it is drawn the perpendicular bisector of the line segment A1, A2, this straight line is called the non-transverse axis of the parabola, or imaginary axis. 2 points, one of each branch of the curve, are symmetric with respect to non-transverse or imaginary axis if they are in a straight line parallel to transverse axis. The intersection of the transverse and non-transverse axis is called the center O of the parabola, and it's the center of symmetry of the curve. In this seventh slide of the second class of chapter 7 is presented the definition of eccentricity of the parabola. Divide the dimension of the focal length by the dimension of the constant of the definition of the parabola, we have the value of the eccentricity of the parabola represented by the lowercase letter e. Since C is given by the line segment A1, A2, and F is given by the line segment F1, F2, then C has value less than the value of F. Therefore, the eccentricity of the parabola is greater than 1. Tracing a perpendicular to the transverse axis, passing through the point A2 and to the continuation draw an arc with center in the point O and with radius OF2, intercepted perpendicular in the point C, it is formed the triangle OA2C. By calling the straight line segment A2C with the lowercase k, and since the dimension of the straight line segment OC is equal to the dimension of the line segment OF2, that is equal to half the focal length, and then applying the Pythagoras theorem in the triangle OA2C, results that the square of the half of the dimension of the focal distance is equal to square of the half of the constant of definition more the square of the dimension of the straight line k. If k is equal to half of the definition constant of the parabola, that is, in this case the eccentricity of the parabola will be equal to the square root of 2, the parabola in this case is called hyperbola equilateral.